Good evening, good afternoon, good morning, people. So today's we're looking at compound interest over different compounding periods, and it's a fairly simple one when you break it down. We should have done some work on recurrence relations with compound interest already, so this is going to be very similar. So we'll jump straight into part A here, and so Brian borrows $5,000 from the bank. Okay. He's given an interest rate of 4.5% per annum, and we're going to let Vn be the value of the loan after n compounding periods. Write down a recurrence relation to the model. If the interest is compounded at these three separate periods. Okay, so first off, familiar one, part A. So the yearly, so it compounds once per year. Okay, so we're talking about that's the interest rate per annum. If it's compounding yearly, then it's happening once a year. So that interest rate is applied once. So the rate of change is equal to 1 plus 4.5 over 100. Okay, so get the figure there of 1.045, and we use that to write our recurrence relation. So we know we've got to mention V0. That's equal to $5,000, the initial amount that Brian borrowed, comma, Vn plus 1 is equal to 1.045 multiplied by Vn. Okay, so we know that whatever the value of Vn is, so let's start at V0 for this, is multiplied by 1.045, then so on from there. Okay, and it keeps building upon itself each time. Going to, just for my own clarity's sake, I'm going to get rid of that comma because it looks like a 1 and put it a little bit better there. Okay, now part B. Part B, the only thing that changes here is R. All right, so if something is compounding quarterly, there's 4 quarters in a year. There's 4 quarters in anything. Okay, so the first thing we need to do is take the interest rate and 0.5 divide it by 4. And we get a figure of 1.125. Okay, so that's the interest rate applied every time it's every time it's calculated throughout the year. All right, so 1.125 4 times a year will add up to the 4.5%, the original percent. Okay, that's not where we stop though for now. To get R, to find our rate of change, we need to take that value and perform the same thing. So 1.125 all divided by 100, and we should have a 1 plus in there. Okay, that will give us a rate of change of 1.0125. Right, now we can write our recurrence relation. So again, same deal as before. V0 is equal to 5,000, the amount that Brian borrowed, and Vn plus 1 is equal to 1.0125 multiplied by Vn. Okay, so every time we apply which is now 4 times a year, every time we apply the interest rate, the value of the loan will be multiplied by 1.0125 instead of 1.045. Right, so that value there is simply a quarter of the original one, but it's applied 4 times. Now hopefully we start picking up on the pattern here and see the monthly How many months is there in a year? Hopefully we all say 12. Okay, so to get R for C, we're going to, let's go up here for C. Okay, to get R for C, we are going to divide 4.5 by 12. And that'll give us a figure of 0.375. So the rate of change is going to be equal to 1 plus 0.375 divided by 100. Okay, so that's going to be 1.00375. Okay, now our recurrence relation, Vn, sorry, I'm going to do it there, not Vn, we know that we start with V0. V0 is equal to $5,000, same as always. And then Vn plus 1 is equal to 1.00375 times Vn. Okay, so the key there, a couple of key things are how many periods there are in the year. That is what you're dividing your per annum interest rate by. And for the recurrence relation, that's the only thing that's changing each time. Okay. So here. All right. And it means that if you were calculating the interest for the year, this one would be calculated 12 times. Okay, that one there. This one would be calculated 4 times. And this one would be calculated just the once. Effectively, all 4.5% per annum interest, but applied multiple times a year in Part B and C's cases, which makes a difference to the overall interest accrued for the year. Okay, hope that was helpful, guys. If you liked it, leave a comment, thumbs up, thumbs down, preferably up, and subscribe. Thank you very much.